Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 10 students and the topic of discussion is surface areas and volumes. We see different solids, cylinders, cones, spheres and cuboids in real life. These are some of the examples given here, like cylinders like Coke can, battery, a drum, the shape of a cup, glass, candle, all are examples of cylinders. Similarly, sphere, we can see football, basketball, globe, all are examples of spheres. Similarly, cone, we take the conical shape of a ice cream, then the shape of the carrot are examples of cones. Cuboids, examples are also plenty. The shape of a radio or the shape of a tetra pack or the shape of a book, all are examples of cuboids. We can also have combination of solids. For example, in the shape of a tent, the bottom portion is cylindrical. We see a cylindrical portion here and the top portion is conical. And in the ice cream, the bottom portion is inverted cone and the top portion where the ice cream portion is there is a hemisphere. A capsule is in the form of a cylindrical figure with a hemisphere at both ends. In the shape of a doll, the bottom can be a shape of a hemisphere and the top is a cone. Now we'll introduce you to the concept of consistent units. Why we have to study these consistent units? Because you will find that in surface areas and volumes a number of figures are there and there are number of formulas. So often we tend to forget and there should be some sort of cross check to know whether what formula we are writing is correct or not. So for that we'll use this topic. This topic is very useful friends, called as consistent units. Let us try to understand perimeter unit. A perimeter can be measured in like meter, centimeter or it could be feet also. Similarly, area could be measured in meter square or volume could be measured in meter cube. When we see area, we find that two length units are multiplied. For example, if we see surface area of a sphere, it is 4 pi r square. So 4 and pi are constant. R square, if we see that two length units are multiplied. Similarly, the one face of the cuboid, if we see the surface area, again two length units are multiplied. Now let us check volume. In volume, three length units are multiplied. For example, if we check volume of a sphere, it is 4 by 3 pi r cube. 4 by 3 pi r is some constant. But if we check r cube, here we see that three length units are multiplied. Similarly, this is the volume of cylinder pi r square h. Again, pi is a constant. We check r square. R square has two units of length and h has one unit. So if we multiply all three, again we have three length units. So friend, this particular check is very important. If you feel that you have forgotten some formula in the examination and you are not sure whether it should be r or r square or r cube, then better to use this technique. That volume will always have three units, area will have two units of multiplication of length and perimeter will have one. This we call it as checking the formula for consistency. There is another important aspect here, that only quantities with same units only can be added up. For example, area and volume, can you add? The answer is no. It doesn't make sense actually. It is like adding weight of a person or height of a person. It doesn't make any sense. Similarly, can we add perimeter and area? No. But can we add perimeter of say square and perimeter of triangle? The answer is yes. If the unit is same, like meter, both are in meters, then we can add. Can we add a perimeter, one is in meter and another in centimeter? The answer is no. We have to bring them into same units. If they are in same units, either meter has to be converted to centimeter or vice versa, and then they can be added up. Now let us define surface areas of some common solids. For example, we have given one cuboid here. it has got 6 faces. So let us take the front face. So what will be surface area, say length into breadth. Exactly at the back of this there is another similar surface. So surface area of those two will be 2lb. Similarly for other 4 surfaces it will be 2bh plus 2lh. So we can write it as 2 common bracket lb plus bh plus lh. This is the surface area of a cuboid. Now from surface area of cuboid we can find the surface area of a cube also. Cube is a special case of cuboid where L equal to B equal to H equal to A, where A is the side of a cube. So it will be 6A square. Surface area of a cube will then become 6A square. You can check it, friends. Now coming to the surface area of a cone. It has got 2 parts. One is the curved portion. The curved surface area is also called as the lateral surface area of a cone. That is given by the expression pi rl, where r is the radius and l is the slant height. This height, slant height, is the need to be calculated for finding the lateral surface area of cone, and pi r square is the bottom surface. In some of the problems it may be given that the bottom surface is open, so you need not add this part, then the surface area will only be lateral surface area. Similarly, a cylinder has got 3 parts. One is the curved surface area, whose surface area is given by 2 pi rh, where h is the height of the cylinder, and there are 2 circular sections here. Those areas are 2 pi r square. Similarly, in your problem, it may be given that one of the lid of the cylinder is not there. Only one side it is closed. So then the curved surface area or total surface area will be 2 pi rh plus pi r square. Now the surface area of a sphere is given by 4 pi r square. And for a hemisquare, once we cut the sphere into 2 parts, the bottom portion will be, curved surface area will be 2 pi r square, half of this, plus we will get additional circular section here. So that area will be pi r square. So if we add 2 pi r square plus this pi r square, it will be 3 pi r square. That will be total surface area. We can check the consistency units for all the expression here, like LB. LB is in meter square. So 2 units are there. 2 units can be added up. Yes, that is acceptable. Here also 2 units of length are there. Here also 2 units of length are multiplied. So they can be added up. Here also we have 2 units of length. Here also 2 units of length, and they can be added up. Here also 2 units of length are there. So we should perform consistency check in our formulas. Now let us take one example here. Now a tent is in the shape of a right circular cylinder up to height of 3 meters. Here we are given 3 meters, and becomes a right circular cone with a maximum height of 13.5 meters above the ground. So this distance is 13.5, this is 3, so this distance will be 10.5. Calculate the cost of painting the inner side of the tent at the rate of rupees 2 per square meter. The radius of the base is 14 meter. A very common way of understanding the surface area is that area or that portion which you can paint. So it should be distinguished from volume. Volume is something like volume of water in a cuboid, or volume of water in a cone, or a cylindrical surface filled with some metal. So that, or filled with air. So that empty space, that place where you can fill something, is the volume. On the other hand, a surface area refers to that portion which you can paint, something like that. So you please understand that. So here we have to use surface area formulas. Now we have a curved surface area of cylinder whose formula is given by 2 pi rh. Pi we have taken 22 by 7, r is 14 given here, and h is 3. We put it, we get 264 meters square. Now for getting the curved surface area of the cone, we need to get the slant height L. Like the pi rl is the formula, so we need to get L first. So this is a right angle triangle where height is 10.5 meter, radius is 14 meter. So the slant height L can be computed as square root of r square plus h square or square root of 14 square plus 10.5 square. On simplification, we get slant height as 17.5 meter. Now the curved surface area of cone can be given as pi rl. Just substituting the values, we get it as 770 meters square. Now we add the total surface area. So we add these two numbers and get 1034 meter square as the total surface area. And the question comes, what will be the cost? We need to determine the cost. For 1 meter square, the rate is 2 rupees 2. So for this many meter square, it will be how much? And we just need to multiply it by 2. In this particular example, we have seen that the equation was very simple, like for 1 meter square it is 2 rupees. So for this many meter square, how much? But suppose I put a little twist here, then how to do it? That's what we are going to discuss further. For example, if the cost to paint 3 meter square is rupees 20, then what is the cost of painting 15 meter square? Here it is not given 1 meter square where we could directly multiply this to. Here we are given if the cost to paint 3 meter square is this, then how much will it cost of painting 15 meter square? Generally, friends, for such problems we always use unitary method. You must understand this. This is very important. In this, what we do is whatever is required to be found out. For example, what is the cost? So that rupees amount we should always put on the right hand side. On the right side, we'll make a small table. You can do this in your rough work. So rupees will be put on the right side, which we want to determine, and we put a question mark. First row we will put it as whatever is given to us, like 3 meter square 20 rupees. So we'll write 3 meter square 20 rupees. 15 meter square, how much? We want to find that question mark. So how to proceed now? How to find what value will come here as question mark? So first is put 20 in the numerator, then 3 in the denominator. So first will be 20 by 3, then into this number, into 15. So we'll get 100 rupees. So for painting 15 meter per square, we require 100 rupees. Now you may be thinking, what is this? Put this in numerator, this in denominator, multiply this. Is there a mathematical basis for that? Yes, there is a mathematical basis for that. When we divide 20 by 3, basically we are converting into a 1 meter square or 1 unit. First we are computing for 1 unit, then we multiply for the number of units it is required. That is why it is called a unitary method. Let us give a slightly more tricky problem here. Here rupees was on the right, now we will change it a bit. For example, in another problem, in rupees 30 we can purchase 7 pens. Then how many pens can we purchase with rupees 65? So our aim is how many pens. So how many pens is number of pens we need to find. We'll put it on the right hand side. We'll make again a small table. Rough work we can do. And whatever is given in the first row we'll put. So rupees 30, rupees 30. Number of pens 7. In rupees 65, how many? So that is our aim. So how to do it, friends? Very easy. To get the question mark, first put 7 by 30. So we have put 7 by 30 into 65. We'll get around 15 pens. With rupees 65, we can purchase 50 pens. So please remember this unitary method. You can practice a few problems on your own. Now let us come to volume. Previously we described surface area. Now we are finding the volume. For example, for a cuboid, volume is L into B into H, length into breadth into height. For a cone, it is 1 by 3 pi r square h. I request you to always check the consistent units formula here. Like 3 units of length are multiplied. Here also 3 length of units are multiplied. Volume of a sphere is 4 by 3 pi r cube. Again 3 units are multiplied. Then for a hemisphere is half of this. So 2 by 3 pi r cube. For a cylinder, the volume is pi r square h. Also sometimes in your examination you may be asked to find volume of a hollow cylinder. Then if R is the outer radius and small r is the inner radius, volume is pi bracket r square minus r square h. Please remember this, friends. These formulas are important. Let us try to solve an example for volume. A vessel is in the form of an inverted cone. Its height is 8 centimeter. So we have an inverted cone here, friends. Its height is 8 centimeter. This height is 8 centimeter and the top radius is 5 centimeters given here. It is filled with water up to the brim, up to the top it is filled with water. We can fill it with water. And then we drop lead shot balls in those water. Then some water is flows out. That is 1/4 of the water. So whatever the volume of this cone is there, 1/4 of that goes out. Why it goes out? Because the water is displayed by the volume of the lead shot balls. Now the question is find the number of lead shot balls dropped in the vessel. So let n be the number of lead shot balls that are dropped in the vessel. Then the volume of lead shot balls is equal to volume of water flows out or the volume of water that is displaced. So n into 4 by 3 pi r cube. For a spherical lead shot ball, this is the volume. So now volume comes into the picture. So this is the volume of the total lead shot balls. And 1 by 3 pi r square h, we have put r1 square. This r1 is the radius of the cone and r is the radius of the lead shot balls. So 1/4 of that volume, 1/4 of this volume is displaced. So now we just plug in the values of different variables like r is 0.5, r1 is 5, h is 8. If we just plug in and solve for n, we get it as 100. So if we drop 100 lead shot balls um, uh, with radius this, it will displace 1/4 of the volume stored in this cone. So friend, with this we conclude this chapter. I hope you like the video. Please subscribe my channel and give a thumbs up. Thank you very much, friends.